All right, guys. I just thought I'd give you a little boost here with 3.1. Lesson 3.1 was all about exponential growth, exponential decay, and such and so forth, I guess. So when it came to story problems, we used formulas that look like this: n equals n sub 0 times 1 plus r to the t power. Okay. I'm looking at number 35, 41, and 46, and just to kind of throw three at you. All right, in 35, it says, I'm just going to read it to you, and I know you have your book, but Jordan wrote an exponential equation to model the cost of gasoline. He found the average cost of per gallon, the average cost per gallon of gasoline for 2 years, and used these data points for his model. The year is 1990. Gas cost what? $1.90? No, $1.19. Okay. And then what is it? 21 years later, in 2011, it cost what? $3.91. Okay. So he's using just 2 years of data. It says if the average cost of gasoline increased at an exponential rate. Okay, so exponential rate, we're looking at growth because it's going up 1 plus r to the t. And then it says you need to identify the rate of increase. So you need r right here. So we need to find r. Well, by looking at the table, in 1990, gas started at 119. Okay, I know I'm going to take 1 plus a growth rate, r, which I don't know, I guess. Now, if I look at the table here, 1990 to 2011 is actually 21 years. And I know gas over the 21 years shot up to what, to 391, something like that. Okay. All right. First solve for r. So it's going to be 1 plus r to the 21st power. I have to divide by $1.19. Okay. So it's a 391 divided by $1.19 equals 1 plus r to the 21st power. Then, to keep solving it, get rid of the 21st power by taking the 21st root. Okay? That 21st root would knock out the 21st power, and you'd end up with 1 plus r. Over here, I'm just going to leave it and go 21 here, 3.91 over 1.19. Okay, and we know to solve for r, we would what? Subtract 1 over, so the answer is 21st power of 3.91 over 1.19 minus 1. And if I'm going to kind of cheat here, guys, because I'm trying to speed up a little bit. If I type it in my calculator, I do get 0.0586. Okay? All right, so that is the growth rate. And that's what they were looking for. Identify the rate of increase. Okay, there it is. Write in an exponential equation to model this. Well, the equation would be the final cost of gasoline equals the starting value. The starting value was $1.19. Okay, my dog is going to bark any second here. Yep, I knew it. So it's $1.19 times 1 plus 0.0586. Okay, sorry guys, gotta let the dog out. I'm back. So, sorry about that. Once again, it's $1.19 times 1 plus 0.0586, which is really 119 times 1.0586 to the t power. That is the formula that you need for part A. So part A is actually right here, and I got this for my r value, growth rate. This is my equation for any time period, right? Okay, part B. Part B says, use your model to predict the average cost of gasoline in 2015 and 2017. Well, okay, in 2015, since we started in 1990, 2015 is 25 years later, so it would be this times 1.0586 to the 25th power equals n. Oh, sorry guys, once again, my dog is barking. All right, so now, if you actually type that in, your answer would be about $4 and what? 94 cents. There you go. That's the average cost of gasoline. 25 years later, this would be the year 2015. Okay, if you did it again for 17, you'd have to change this to 27th year, right? So it's this 1.0586 times $1.19, which would give us in the year 2017. Once again, I'm just using my book. My book says $5.54. Okay? All right. And I'm going to keep moving my paper up a little bit so you can see what I'm doing. Okay? All right. Part C, when will the average cost per gallon of gasoline exceed $7? So basically, I'm taking this equation right here, and I know the final amount is $7. So I want it to be greater than 7. And what do I want to be greater than 7? 1.19 times 1.0586 to the t power. Okay? So on this one, because you have the exponent as a variable, we will solve this eventually by using logarithms, but today we're just going to graph it. Okay, and I would graph it like this. y1 equals this. y2 equals this. And I do know this is 7. So, I mean, I don't have my graphing calculator with me, guys, so I'm just going to kind of show you. I would probably go something like $7. That would be this equation right here. And then this one, I know when time is 0, time equals 0 right here, I know this to the 0 power is 1, and 1 times $1.19 is $1.19. So what I do know is we start at $1.19. I know this number is bigger than 1, so I know it's growth, and it's going to go like this. Okay? And I would use my graphing calculator to get this intersection. So when does it reach 7? Right about there. And the graphing calculator, I'm not going to show you that because, again, it just slows me down. I'm going to say, well, my book says somewhere during 2021 to 2022. So that must mean the answer is what? 2021 would be 21 years after 1990. So this number right here has to be something like 21 point something. And my book doesn't tell me. So what they did is they added it to 1990. Okay. 20 point something. I'll just say 4. And so that would make it what? 20. Oh, you guys, I'm so sorry. It's not 21. It's 31. 31 point something. Okay. And if you added 31 to 1990, the year would be 2021 to 2022. And that's what they came up with. But they're just using the graphs to actually find the answer. And 31 told me 31 years after 1990. Okay, part D, I'm not going to write this out, but part D says, why might an exponential model not be an accurate representation of the gasoline prices? Well, I think you guys are pretty, you're at the age where I think you might have noticed gasoline goes like this. Today it might be $3. Tomorrow it might be $4. The next week it might be $4.25. The next week it could be down to $2.75. It doesn't vary that much, but gasoline is very, very typically an up and down kind of price. It really depends on how the economy is doing. So we can't really put a lot of faith in this graph, okay? You'd have to word that out the way you would want to word that out, okay? All right, that's 35, A, B, C, and D. Okay, 41. Okay, 41 talks about encyclopedias, which you guys might not even know what they are. Just big books that have a lot of information. I used to deal with that back in high school and college. Okay, the number of articles making up an online open content encyclopedia increased exponentially during its first years. The number of articles, A of T, okay, A is articles, right? T must be time, I'm thinking. Okay. T is the years after 2001. So T would be number of years, what? After 19 what? Nope, I said 2001, my fault. 2001. Okay, there it is. And it is given by this 16,000 what? 198 times 2.13 to the what power? T power. Okay, all right. Here it goes. Part A. According to this model, how many articles made up the encyclopedia in 2001? Okay, well, how many articles in 2001? Well, the number of years after 2001. The year 2001 is, there's been no years past 2001, so we're really finding this, aren't we? A of 0. So if you put your 0 into your formula, 2.13 to the 0 is 1, and 1 times this number is this number. So how many articles? 16,198. Okay. At what rate is the number of articles increasing? So to find the rate, this is how it starts, right? We start with 16,198. We take it times 1 plus r. Well, the number inside is 2.13. To get 2.13, you'd have to have 1 plus 1.13, which would give you the 2.13. So this is the growth rate, and that is 113%. That's quite a growth rate. Okay? All right, next up. During which year did the encyclopedia reach 1 million articles? Well, when did it reach 1 million articles? Okay, so you would probably, let's see here. I got to read this a little closer exponentially. Okay, yeah, so we're going to have to do this. Take your equation, 16,198 times 2.13 to the t power. When does it reach what? 1 million articles. Okay? Again, because the variable is in the exponent spot, we'll solve this with logarithms in about another week. Today, it's just graphing. So call this side y1, call this side y2, set it up. Although, be careful with your window, because this number is 1 million. So you're probably going to want to get up to around, if this is a million, you probably better get up here. Your window size much bigger than a million, maybe 1.1 million, something like that. Okay, this number, 16,198. If you say let t be 0, then that is the y-intercept, 16,198. Okay, and then you're going to have to play with this. I know it's growth, it's doubling, so it's going to grow, it's going to double pretty fast, and there's the answer right there. If you come down, that's the x value that makes, that's the t value that makes this side equal 1 million. Okay, so what is time? Again, I think your window, you're going to have to get out here somewhere around, what is it? T stood for what again? Years after 2001. So I would probably go at least 20 to 30 years out here. Okay? Anyways, the answer is, I'm just going to give it to you because you'll just find it with your calculator. It says the answer is 2006, which would mean the answer would be somewhere around 15. So this number down here is 15, which leads me to believe part B, 15 years after 2001 is 2006. Okay. Part C, what does part C say? Part C. Predict the number of articles there will be at the end of 2018. So at the end of 2018, How many articles? Well, 2018, I mean, you started in 2001. So 0 represents 2001. 1 represents 2002. This would be 17 years after 2001. So let's put this in your formula. And your formula was 16,198 times 2.13 to the 17th power. Punch it in, and what do you get? You should get, you're going to get a large number. 6,193,000,000. 193,554 articles. And there you go. Okay. I was trying to do one more problem. That one more problem is 46. So I'm just going to jump over here and do 46. 46. Okay. It says 2 to the x is less than 4. And it does say to use your graphing calculator. Although this one, to be honest, we can just do this one pretty quickly. This is 2 to the x, and we can make this base 2 by saying 2 squared, right? So for this to be true, 2 to the x must be less than 2 to the second. Doesn't this number have to be less than this number, right? So to me, the answer is x is less than 2. But if you actually did it by the graphing calculator, they would want you to do this. Call this side y1, call this side y2, and then if you graph it, it kind of looks like this. 1, 2, 3, 4. Here's 4, horizontal. This one is 2 to the x. Well, 2 to the x is going to be, if you let x be 0, the answer is 1. If you let x be 1, the answer is 2. If you let x be 2, the answer is what? 4. And here it goes. Kind of like this and this, right? Okay, so if you look at this, when will this function be less than this function? Well, all these, here is 2 to the x. All of these answers are y's. These y's are all less than 4. So you'd say from 2 what? To negative infinity, right? Or you just probably could say x is less than 2. And that's what I said right there, okay? If you look at 48, though, 48, negative e to the x, negative e to the x is greater than negative 2. And again, here you could do the same thing. Again, without a graphing calculator, it's kind of hard, but you'd say something like y1 equals this, y2 equals this. And here's negative 2. Okay? And I believe if I just want the y-intercept, put 0 in for x here, and negative e to the 0 is 1, and negative e to the 0 is 1, and this would be negative 1, so I guess there it is, right there. This one is going to kind of ride like this, underneath the x-axis, and it will come down. And the reason that, here's how I kind of know that, e to the x. E to the x, this is a base bigger than 1, so I do know this one starts at 1, because e to the 0 is 1. And I know it's growth, so I know it goes like this and this. But what I know here is this is a reflection over the x-axis, so that's why it's going down. Here's the deal, though. You have to tell me when is this function greater than this function. Well, this is negative e to the x. This is negative 2. Greater, all these y's values are greater than negative 2. So it's basically this number right here. What's that number? And it turns out it's 0.69. You'd have to do your intersection button on your calculator to get that. So to me, the answer is anything less than 0.69 or negative infinity to 0.69. Okay? That's 4 problems. Maybe that helps. I hope it did. All right? See you tomorrow.